Hey guys, today we're going to be talking about linear transformations. Now, you did transformations last year. Most of the time would just be an ordered pair or maybe a two-dimensional object on a coordinate plane. Talked about reflections, translations, reflections. I think I said that already, dilations. So today we're going to be applying some of the same principles, only this time we're going to be applying them to linear functions. Now, yesterday we talked about parent functions. We talked about linear parent functions. We talked about quadratic parent functions. We talked about exponential parent functions. Today we're going to focus on linear functions, okay? So to begin with, I went ahead and tried to save us some time. I try to keep these videos under 15 minutes. You can see the parent function. I've worked it out in blue, which basically means whatever x is, y is. So if x is negative 2, y is negative 2. If x is negative 1, y is negative 1, because x equals y. So you can see what kind of a line that creates. Now, what if we toss things up? What if I put a negative in front of f of x? Now, remember, f of x is the y. X equals f of x because x equals y. So what if I put a negative in front of the f of x? So in that situation, it's the same as multiplying multiply y by a negative 1. That's what it means. So what would happen then is, instead of this f of x column, I'm now going to change. I'm just going to multiply everything by negative 1. So I end up with a 2, a 1, a 0, a negative 1, and a negative 2. Let me rewrite that in there. And I went ahead and plotted those points in red. And you can kind of see what's happening here. I'm going to go ahead and connect them. Now, the original parent function is there. I have it written. And I went ahead and added an A and a B point because I feel it's really important for you to understand what just happened. You need to understand what's happening to the A and the B point. So if you look, the A was below the x-axis, and now it is above the x-axis, and the B was above the x-axis. Well, I didn't write it down, but now it is below the x-axis, because what happened? The function, it reflected over the x-axis. So when I put that negative in front of the y, the x-axis. When I would put the negative in front of the y, it flips that line over the x. Now, what if I put the negative in front of the x? So if I put the negative in front of the x, it's the same as multiplying x by negative 1. So what happens? This becomes a positive 2, a positive 1, a 0, a negative 1, and a negative 2. So I'm going to go ahead and graph those points, and you can see kind of what's happening here. And I should have, and I'm going to go ahead and erase this. I had this intent of being so good about doing this in different colors. So this is a negative x, and so that's going to be a positive 2, a positive 1, a 0, a negative 1, and a negative 2. So what happens? Let's go ahead and graph these points. I'm going to ignore this middle now, and I'm going to do 2, negative 2. 2, negative 2 is right here. 1, negative 1 is right here. 0, 0, and you can see it's laying right on top of that other function, negative 1, 1, and negative 2, 2. So again, I could connect all those lines, and I could put it right over that red line. It's hard for you to see, but remember I started down here. Now the original function, the beginning was here, and now it has jumped over here. So what did it do? It reflected over the y-axis. So again, I didn't signify the B as much, but you can kind of see if the A is now here, then the B is now over here. So it reflects across. So if I put a negative in front of the Y, it reflects across the X. If I put a negative in front of the X, it reflects across the Y. You can remember that, right? Easy peasy. Okay, let's look at the next one. The next one is if I put something, what happens when the following occurs? What if, compared to the original function, A is greater than 1, or when A is less than 1, which means what I'm going to do is instead of this basic function here, I'm going to put instead of it being just a x and a y, what if this was 2y? Now, again, if you look here, the original function is f of x. I'm putting a 2 in front of it. So what does that do? So if I looked, if it was originally -2, it's now -4. -1 is now -2. 0 is still 0. 1 is now 2. 2 is now 4. So what happens? Again, I went ahead and graphed some of these points, and you can see that I'm going to go ahead and write what's happening as I'm speaking. The line, it got steeper as compared to the parent. This is called a vertical. Whoops, got ahead of myself. That's an L. Here's the S, a vertical stretch. That is the word that you're going to want to remember, the vertical stretch. So the vertical stretch, it got steeper. So a stretch is like stretching. All right, I don't know. Whatever works for you, whatever you can remember. Now, what happens if I put a number less than 1 in front of the Y? That would mean that's the same as 1/2 whatever Y is. So if I did 1/2, this would be a -1. This would be a -1/2. 0 would stay the same, 1/2 and 1. So what would that look like? Let's go ahead and graph it and see. So -2, -1, -2, -1, -1, a half, -1 and -1/2, 0, and then 1.5, and then 2 and 1. So what is happening now? If you look, the line is less steep. And we call that vertical compression. I'm going to go ahead and change the color. I know we're coming up to Christmas, but I cannot, with all this red and green, I can't help but think about Christmas. Let's move on. Now, what happens if I add to the function? So what happens if I add or subtract to the original y? That would mean the same as, instead of y, it would be y plus 3, since that's the example I'm giving you. So what happens to that? That just means, again, we always start with the parent function. I'm going to add 3 to the y value, and I end up with a 1, a 2, a 3, a 4, and a 5. And when I graph it, this is what it looks like. Well, it looks like I already started it. And then the other color. So what happened here? What happened is the line moved up. Because it's a positive value, it moved up 3 units. We call this a vertical translation. So we've talked about a stretch, got steeper. We talked about a compression, it kind of flattened out. Now we're talking about a translation. And this is, if you remember from last year, is like a slide up and down. And it's not just a vertical translation, it's a vertical translation up 3 units. All right, moving on. Now, I bet you can guess the next one. It's -4, so that is the same as taking, let me change color because it's so fun to do. We'll go back to green. It's the same as taking y and subtracting 4 from it. So we end up with a -6, a -5, a -4, a -3, -2. And I'm really trying to save some time here. So I'm going to take that original, I'm going to move it down. And so this whole line gets moved down. So this example, it's a vertical because it's going up and down. It's important you remember the word vertical. It's a vertical translation. And it's not just a vertical translation, it's a vertical translation down 4 units. Whoa. And it's super important that you remember those details. Well, it went away. I don't want to spend time rewriting it. Vertical translation down 4 units. All right, trying to stay under 15 minutes. Sorry if I cut you short. You can do it. Ask me questions if you need help. And I'll see you later. Bye-bye.